Hello friends, today in this fifth lecture of the Laplace Transform, we shall now study the evaluation of the definite integrals. So, to start with this example asked in the university examination, this example is if the Laplace transform of J0 of t is 1 upon under root of 1 plus s square, then integral 0 to infinity t into e to the power minus 3t into j0 of 4t dt, value of this integral is 3 upon 125. So how to prove or how to evaluate this definite integral, and its value is 3 upon 125. So we shall see this. We want to evaluate this. Consider integral 0 to infinity e raised to power minus 3t into t into j0 of 4t dt. Now compare this definite integral with the fundamental definition of Laplace transform of some f of t. Its definition is integral 0 to infinity e to the power minus st, here it is 3t minus 3t into f of t dt. So if we compare this definition with the definition of Laplace transform, integral 0 to infinity e raised to power minus st into f of t dt. So on comparing, we see over here that the value of s is 3. Moreover, the value of f of t, the function is t into j0 of 4t. So, we observe over here that the value of this integral is nothing but the Laplace transform of t into j0 of 4t at s equal to 3. So, this is, on comparing, it is equal to Laplace transform of t into j0 of 4t at s is equal to 3. So we would be finding out Laplace transform of t into j0 of 4t. We are given the Laplace transform of j0 of t is, since Laplace transform of j0 of t is 1 upon under root of 1 plus s square. So from this Laplace transform of j0 of t, using this scaling property, we would be finding out the Laplace transform of j0 of 4t. Therefore, by scaling formula or scaling property, Laplace transform of j0 of 4t is equal to 1 by 4, 1 upon a times f of s by a. F of s a is 4 here. So it is equal to 1 by 4 times into 1 upon under root of s by 4 whole square. That gives me the Laplace transform of j0 of 4t. So on simplifying this, this is equal to 1 by 4 times 4 upon under root of s square plus 16. So it is equal to 1 upon under root of s square plus 16. Laplace transform of J0 of 4t. Now, we want perhaps the Laplace transform of t into J0 of 4t. So here I would introduce or I would use the multiplication by t property. Therefore, now by multiplication by t property, Laplace transform of t into J0 of 4t is equal to minus d by ds of f of s 1 upon under root of s square plus 16. Or minus d by ds of s square plus 16 raised to power minus 1 by 2. So differentiating this with respect to s, that is equal to minus into minus 1 by 2 into s square plus 16 raised to power minus 3 by 2 into 2s. So it is equal to s upon under root of s upon s square plus 16 raised to power 3 by 2. This is the Laplace transform of t into J0 of 4t. Therefore, integral 0 to infinity e raised to power minus 3t t into J0 of 4t dt is equal to f of s at s is equal to 3. So s upon s square plus 16 raised to power 3 by 2 at s is equal to 3 upon 9 plus 16 raised to power 3 by 2. 3 upon 9 plus 16, 25 raised to power 3 by 2. 25 raised to power 1 by 2 is 5 and 5 cube is 125. So it is equal to 3 upon 125 as required by this answer of this problem. So that is how we evaluate the definite integrals. We shall solve one more example. आवाज ओछो करके तो धीरे हो रेडो ना कीजिए. Second example, evaluate integral 0 to infinity cos of 6t minus cos of 4t divided by t into dt. Again, if we compare this definite integral with the fundamental definition of Laplace transform, here f of t is cos of 6t minus cos of 4t upon t, number 1. And what is S? S is not mentioned here over it. But perhaps it can be considered as integral 0 to infinity e raised to power minus 0t. E raised to power minus 0t can be considered as 1. So, S is 1 here. So, integral 0 to infinity e raised to power minus 0t cos of 6t minus cos of 4t upon t. So, to evaluate this integral, we would be finding out the Laplace transform of f of t cos of 6t minus cos of 4t upon t at t equal to 0. So, first, what is the Laplace transform of cos of 6t minus cos of 4t? Laplace transform of cos of 6t, s upon s square plus 36 minus that of 4t is s upon s square plus 60. This is the Laplace transform of cos of 60 minus cos of 40. Now, I would be using the division by t property. Now, by division by t property, Laplace transform of cos of 6t minus cos of 4t upon t, that becomes integral s to infinity f of s ds. This is f of s, Laplace transform of cos 6t minus cos 4t. So it is s upon s square plus 36 minus s upon s square plus 16 ds. Integral is very easy. If you multiply and divide by 2, so numerator becomes the derivative of denominator. So integral is log of the denominator. It is equal to 1 by 2 times log of s square plus 36 minus log of s square plus 16. The limits are from 0 to infinity. That is further equal to 1 by 2 times log of s square plus 36 upon s square plus 16 s to infinity. Now, to employ the upper limit, I will divide numerator and denominator by s square. So, 1 by 2 times log of numerator is 1 plus 36 by s square upon 1 plus 16 by s square minus. For s equal to s itself, it is the function itself, log of s square plus 36 upon s square plus 16. So it is equal to 1 by 2 times. Now if s tends to infinity, here numerator and denominator becomes 1. Log of 1 is 0. So minus times log of a by b is equal to log of b by a. So it is equal to 1 by 2 times log of s square plus 16 upon s square plus 36. That is further equal to 1 by 2 times log of 16 upon 36. If I put s is equal to 0, f of s at s equal to 0, because s is 0 here. So it is equal to log of under root of 16 by 36 is 4 by 6, or in particular it is equal to log of 2 by 2. So value of this integral is log of 2 by 3. Log of 0.666. That is how we evaluate any such type of definite integral. We just evaluate the Laplace transform of the hidden function and put the value of s. Now, we shall Laplace transform of periodic function. Let f of t be a periodic function with period t is equal to capital T. The periodicity of function f of t is capital T. What does it mean? That is f of t plus capital T is equal to f of t. Then Laplace transform of this periodic function f of t is equal to, the formula is 1 upon 1 minus e raised to power minus s capital T into integral 0 to capital T e raised to power minus st into f of periodic function t. For any periodic function of period capital T, this formula can be used to obtain its Laplace transform. So note this formula carefully. Subject to this, we would be finding out the Laplace transform of some periodic function. So let f of t be equal to a sine of pt when t lies between 0 to pi by p, and it is equal to 0 when t lies between pi by p to pi by 2p. Here, where f of t plus pi by 2p is equal to f of t. What does it mean? This given function f of t is periodic, whose period is pi by 2p. This function is also called as half wave rectifier. If this is t axis and this is f of t axis, from 0 to pi by p, this is suppose pi by p, and this is 2 pi by p, 3 pi by p, 4 pi by p suppose. From 0 to pi by p, it is a sine pt. So it is sine wave function between 0 to pi by p. From pi by p to 2 pi by p, it is 0. So it is 0. Again from 2 pi by p to 3 pi by p, it is sinusoidal. again it is 0, again. So it is half wave rectifier. We want to obtain the Laplace transform of this function. So just we have to use the formula. We know that WKT means we know that the Laplace transform of periodic function f of t is equal to 1 upon 1 minus e raised to power minus s capital T integral 0 to t e raised to power minus st into the f of t dt. What is the value of capital T? Capital T is equal to pi by 2p. It should be 2 pi by 2. Sorry, 2 pi by 2. Period is not half, perhaps 2 times. The period is 2 pi by p. So, now, I shall substitute the value of capital T in this formula. Therefore, the Laplace transform of the given function f of t is equal to 1 upon 1 minus e raised to power minus 2 pi s by p into integral 0 to 2 pi by p e raised to power minus st into f of t is f of t. That is further equal to 1 upon 1 minus e raised to power minus 2 pi s by p into. Now this integral 0 to 2 pi by p is splitted into 0 to pi by p and from pi by p to 2 pi by p. In this interval it is 0. So this integral reduces to integral 0 to pi by p only, e raised to power minus st, and in this interval 0 to pi by p function takes the value a into sine of pt into dt. That is equal to a upon 1 minus e raised to power minus 2 pi s by p into the formula integral e raised to power ax into sine bx dx is e raised to power ax upon a square plus b square, a sine bx minus b cos bx. I am using that formula. So it is equal to e raised to power minus st upon minus s square means s square plus p square times minus s sine pt minus p cos pt. Employ the limits of t as 0 to pi by p. That is further equal to a upon 1 minus e raised to power minus 2 pi s upon p times 1 upon s square plus p square. This is also independent of the limits t. Now, for the upper limit pi by p e raised to power minus pi s by p into minus s sine pi minus p cos pi. This is the upper limit t equal to pi by p. Now for lower limit t equal to 0, it is e raised to power 0 is 1 into minus s into sine 0 minus p cos 0 that reduces to a upon 1 minus e raised to power minus 2 pi s by p into s square plus p square times e raised to power minus pi s by p into sin pi is 0 plus p, because cos pi is minus 1 into minus p is plus p, minus e raised to power 0, sin 0 is 0, cos 0 is 1, minus into minus plus p. So that reduces to AP upon, taking out this p common, 1 minus e raised to power minus 2 pi s by p into s square plus p square times 1 plus e raised to power minus pi s by p, that is equal to, now see here this denominator, 1 minus e to the power minus 2 pi s by p, this second term, it is exponential term which is square of e raised to power minus pi s by p. It is square of e raised to power minus pi s by p. So it can be factorized as 1 plus e raised to power pi s by p. The factors of this is 1 plus e raised to power minus pi s by p into 1 minus e to the power minus pi s by p into s square plus p square. So that reduces to, one factor goes, AP. So that is equal to AP upon 1 minus e raised to power minus pi s by p into s square plus p square. That is the Laplace transform of this half wave sine rectifier function, which is required Laplace transform of given periodic function. So with this, we shall finish today's lecture. Thank you very much.